Hi Spring fans, welcome to another installment of Spring Tips. In today's installment, we're going to look at OAuth, and we're going to look at it in particular in terms of the Spring Authorization Server. OAuth, my friends, is a very simple, it's not simple, it's a well understood protocol, and if it's not understood, then there's certainly a lot of good information out there. But the core thesis, the core tenet behind it, the core conceit of OAuth is that given a request to a particular service, do I have the information to allow that request to go through? And I want to keep that information centralized, right? So imagine I make a request to a web service and I want to get a response back. Well, I need to present some sort of credential allowing that service to know whether it should allow me through. The problem comes, of course, when I start sending usernames and passwords around. Passwords are a no-go, right? You don't want to send passwords over the network. Ideally, you keep that password to yourself and keep it only in one place. You've probably done something like Google login, where you go to a website, click on the login with Google or login with Facebook or login with Apple, and then you get redirected to an Apple website or Google or Facebook or whatever, and it's got a padlock there indicating SSL is on and enabled, and it's hopefully you've checked it and you can confirm that it's valid. That padlock is very important, and that redirect is very important because what it means is that when you log in and when you enter your password, you're doing so only on Google or Apple's or Facebook's or whatever's well understood, well-known servers. Only they have your password. That then redirects you back to the original web app, and that web app could be some shopping website. It could be, almost anything, content, all this stuff that people do, reading articles and blogs and videos and whatever, all that kind of stuff requires some sort of login, right? So you get redirected back to those websites. They now have a token that they can use to make requests on your behalf to a web API, right? That token is their handle. It's how they can authenticate themselves on your behalf. Namely, though, they don't have the password, so they can't, as malicious actors, lock you out of your account, and they can't, change important things that the API developer didn't intend for them to be able to change, right? They can only do what that token allows them to do. You can also, a lot of times, when you do this redirect, you get asked, do you want to allow them to see your photos or see your contacts or whatever, right? And you can say, yes, I want to allow this, this, and this, or you can deselect them as well. This is very important because what it means is you're no longer giving them carte blanche to do anything they want with your data stored in Google. They just have well scoped out, limited access to different permissions. This is a very good system for security. And it's a standard, so anybody can implement it. You can have your own auth.yourwebsite.com, right? And then that could be the single hub for all authentication in all of your services across your organization. You get it right once, and then you just use Spring to lock down those other apps and have them check that authorization server for permission. Well, the question then, of course, is what authorization server should you be using? You could use Okta, certainly, or Auth0. I think they're the same thing nowadays, but that's an option. You could use Keycloak, they're from Red Hat. That's a good option as well. There's lots of good options. But my friends, my favorite option, the one I use all the time for my own stuff personally and also just in general, is the Spring Authorization Server. So if you want to build a new authorization server, you start here. As always, on my second favorite place on the internet, start.spring.io. Let's go ahead and build a new application. I'll accept the defaults. I want Gradle. I'm going to name it Auth Server. I'm going to use Java 21. We're going to use GraalVM native image support. We're going to use the OAuth authorization server support and Spring web support. And I'll just hit generate. And we're going to open this up in our IDE. We have the auth server open, the code base. All right, we have the OAuth auth server open. Let's go ahead and start configuring it. So first things first, we want to define some users. And again, this is just regular Spring security. So we're going to create a in-memory user details manager, okay? And this is just going to handle the question of authentication, right? So we need to provide some users. So we're just going to call this 1 equals user with default password encoder dot roles. And we'll say that this is a admin. The password is PW. We'll build it, right? And then we'll do the same thing for the other one, 2. And we're just going to call this user, right? So this would be user and admin, and this will just be user. And 1 and 2. Okay, so we got 2 users now in our system. Now remember, in Spring Security, you have 2 concerns, authorization and authentication. Authorization answers the question, what permissions does this person have? authentication answers the question, is this person who he or she says they are, right? This thing is a user details manager. It is in turn used as part of the authentication, right? It answers the question, who is this user? Is that user Josh or Jane or whatever, right? So we're going to define a bean of this type. Spring Security will discover it, and these are the users for our system. Now, of course, this is Spring Security. You could plug this part in and have it get that information from anything else. You could get it from Active Directory or LDAP or whatever, right? Or a SQL database. You could actually create your own implementation of this interface, user details manager, right? Or user details service, more likely, right? If you create this implementation, Spring Security will plug that in for you. So that's the Java code. Let's configure our OAuth. All right, I've pasted this in from another machine so you can kind of see. So we have a client, right? This is the logical name for the device or browser or app or whatever that is going to be handling OAuth authentications. Okay, so you might have, if you've ever developed an OAuth application for Twitter or for Facebook or whatever, or I mean, it's not Twitter and it's not Facebook anymore, is it? It's X and Meta. There's usually like a developer dot page, right? Developer dot one imagines google.com or something like that, where you can register a new app. They call them apps usually. Think of that. You're registering a new app here, and you're telling Spring Security Auth Server, the authorization server, and you're telling the Spring Authorization Server that this app that you're defining, we're going to call it client 1, has a client ID of client and has a password. Okay, the client secret. So all uses of this client need to provide the client and the password. So the question then is, of course, how do you get a bcrypt encoded password, right? Well, remember, behind the scenes, this is using the same configuration mechanism as you would use in any Spring Security app. It's using a password encoder. And by default, that password encoder expects to find a password with the logical name of the encoding and then the actual encoded password. So this way it knows to use the bcrypt password encoder to work with this string here. So we want to create our own password. I'm going to go to the Spring CLI and I'll use encode password. And I'm going to use a very terrible password called password. Yes, don't tell Rob Winch. So here's that. I'm going to copy this and I'll just paste it in there. So there's my client secret. So then we're going to configure the client authentication method. We're just going to use client secret basic. That's this bit right here, sending the username and password here. We're going to use client authentication method, client secret basic. So basically what we're going to do is treat the client ID and the client secret as a username and password, which you're then going to send to the auth server to then eventually get a token, right? So we're going to do that. And then there's different kinds of flows. The auth server supports different kinds of flows. Client credentials, for example, if you want to do client authentication only, if you want to do authorization code or refresh token or whatever, there's different kinds of flows here. There's a lot of nitty gritty here and that you have to kind of get into to appreciate it, but it's all part of OAuth, right? And just specify these, you'll be fine. Then we have the question of where do we want requests once authenticated to go back to? So we're going to tell our auth server that when a client successfully authenticates here on the auth server, and they've identified themselves as client 1, then we should send it back to this host and port on our local machine. Notice that we're sending it to 127.0.0.1. So we're going to access our app in terms of this URL, but we're going to access the authorization server in terms of localhost. You have to keep those two things separate. So this is localhost, right? This is the actual IP for localhost, and then we have actually the alias localhost, the DNS host's name called localhost. They're not the same, however, in terms of cookies. So it's useful to keep that, right? Remember, we need to have two separate cookies, both tied to, all tied to the things on this same machine. So if you run into an issue, remember to try changing this to 127.0.0.1. Then we have the question of what permissions do we want to grant the authenticated user? What can they do in the system? Well, we have OIDC, and that's like the standard there is OpenID. You can also create arbitrary ones, user.read, user.write, and eventually those are mapped to the scopes that we described here, user, etc. Okay. And then of course, if we're asking for particular permissions, do we just want it to be like a carte blanche? Here's all the permissions, or do we want to ask them to specifically enumerate and then grant certain permissions? And if so, you specify this, and we want that. And of course, just to make it easier to see what's going on, I've got the logging level here set to trace. Okay, so this is all going to run on the default host and port, right? So run. I forgot to do the username. Okay, I'm going to call this 1 and 2. Alrighty, it's up and running. Good. So it doesn't know us. It's asking us to log in. We can do that. The username is where's our username? Well, here it's U1 and PW, right? So 1 PW. Nothing particularly interesting, but fine. So the server's up and running. Good. Now let's actually build an API that we want to protect using the Auth server. Okay. So we'll go back here. Start.spring.io. Okay, we're going to use Java 21. We're going to call this the resource server, right? This is our API. We're here. Oops. Call this resource server. But then we're going to add the resource server and the GraalVM native image support and the web support and Java 21. We'll hit generate. This one's going to be a little bit more involved. We're going to create a simple endpoint, okay? And this endpoint is going to return a greeting to the user. The first thing, this endpoint is going to return a greeting to the authenticated user. So we're going to demonstrate a couple things here. We're going to demonstrate protecting a web endpoint and also protecting things based on method invocation, okay? So we'll create a greetings service, and we'll create a public map string greet map.of. Import that class, okay? And we're going to say message is equal to, I'm going to have to get the current user, okay? So we'll do this. We'll do JWT. I'm going to look at the security context holder, get the current context, get the authentication, and then get the principal name. And we're going to cast that principal to JWT. So now we can say, hello, JWT.get subject. All right, very good. So we have our simple endpoint, our simple service. We want to lock this down. We want only people who have the right scopes to be allowed to use this. So has authority, scope, user.read. Okay, so we're telling Spring Security only those who have this particular scope are going to be allowed to invoke this method. Okay, now we have an endpoint we're going to lock down. And of course here, we'll just delegate it to our service. So greetings service, inject that, control enter, this dot okay, not bad. We've got our simple service, our simple endpoint. Obviously, this is just a simple API, and people aren't going to go to this API directly, but it's nice to see what's happening here, okay? We need to tell Spring Security, which it exists in this resource server, where to go to find out whether the request that we're getting and the token that's in that request is valid. And we do that in the configuration. We want the thing to run in port 8081, and we're going to point it to the issuer URI for the resource server, and that is, of course, our auth server, localhost 8080. Let's restart this, and then finally, we want to build a client. Okay, now remember, the client's a little bit interesting. It's the thing that's going to be the first port of call for requests coming in from the actual user. So when they open up their browser, they're going to hit this, right? A client might be an iPhone app, it might be an Android app, or it might be a web view of some sort. And if it's a web view, this is the client, right? This is the first thing that gets the request from the user. It is also where you want to have the logic to sort of incept the token by going to the auth server if it doesn't already exist in the body. And that dance, that three-legged OAuth dance, that's the duty, that's the job of the OAuth client. So we're going to go here. We're going to go here, and I think you can guess what we're going to do next, right? So OAuth client 21, OAuth client, right? Easy enough, but also consider what we're doing here. This is going to be the first port of call. Where's the HTML? Where's the web app, right? Where's the thing that the user is going to talk to? And so what we want to do is make it so that when somebody goes to this endpoint, they actually get the view of the system. And that might be a React app on a CDN somewhere. It might be a browser. It might be anything. But the point is, you want to have this app handle the request and handle getting the token, but also you want it to be a proxy to show the view. The React app might be deployed on some CDN. You want to send it to that. You also want to send all requests from within the browser to the the correct backend API that's been secured by the OAuth client support. So we also want to add Spring Cloud Gateway. Okay, and we're going to actually add the reactive web support. And this is going to act as a proxy, a micro proxy. It's going to proxy requests after the OAuth client has obtained a token. It'll forward that request onward to a backend API, including our resource server. So it'll get the token, send and then act as a token relay using Spring Cloud Gateway to then send that request to the backend. You could also have this act as a relay to your CDN React application as well, right? So here we go, OAuth client. Okay, here's this. And this is super easy, right? We just say route locator. You've seen me do gateway demos a million times, right? Route locator builder, routes.build route. And then we're going to create a route specification. And here we're going to say that we want to match all requests to /. And we want to add a filter, which is the gateway filter spec for token relay. Okay, and then once that's done, we're going to forward the request to localhost 8081. That's our OAuth API, the resource server itself, right? Not the auth server, but the API that we want to actually expose. Okay, so the request comes into the gateway, to this proxy, to the client, right? This client's going to run on a separate port. It goes to this /. When that request arrives, we're going to act as an OAuth client, and we're going to get a token. Once we get routed back, it's going to dump us back on this app. Once that happens, we're going to have a token in the session, right? The client will be able to send a token, and then we send that token while we're proxying the request to the backend service. So if we call /, just /, it's going to send us to / over here on that. You can also do wildcards. You can have it forward all of that stuff after the wildcard. You can do multiple routes. You can have a route for like API dash whatever, and then have that forwarded to the backend API, and another one for just the view or whatever. But the point is, this is very simple. I'm taking the gateway request and forwarding it to a backend resource server. Okay. All right. So this is the OAuth client. Let's configure it. And here, I'll copy and paste. So what are we doing now? We have a client running on port 8082. Recall that in the auth server, we have a redirect URI to 8082, right? So we're just redirecting to this gateway. And we're acting as a client, so we've configured the Spring Security client configurations. We're saying we want to register a client. It's called Spring. The provider is Spring, okay? Well, what is Spring, right? Well, now we have a definition for a client provider called Spring. The issuer URI is here. That's the auth server. And the client ID is called client. The password is called secret. So here we're acting as a client to the auth server. So we're telling this Spring security code in the client how to, what scopes we can expect to get, what scopes we want, what client ID and client secret to send, etc. So we're acting as a thing that's consuming the auth server, not the thing that's providing the services of the auth server. Okay, we've got an authorization grant type, client authentication method, a redirect URI. So here we're saying there's a nice templating mechanism in this. So the base URL, the redirect URL is going to be / login OAuth2 code and then registration ID. What's the registration ID? Well, it's Spring, right? Like that. And you can see that was also what we had in the registration of the client in the auth server itself, right? So login OAuth2 code Spring, login OAuth2 code Spring. Okay, I think we're ready to go. Let's just make sure everything looks okay. So client ID is client secret is password, actually, right? This is what we use the Spring CLI for. So it's good that we check that. Authorization code, client secret basic, specifying the redirect URI. Okay, great. Let's run this. Okay, it's up and running on port 8082. Let's try it out. So we'll go to 127.80.82. And it's asking for 1 and PW. These are the users that we defined in the auth server, right? It's saying, okay, user wants, the client called client, which is, but imagine like iPhone app or Android app or whatever, your company dash iPhone or something like that, right? You can call the client anything you want. Wants access to your account for the user called 1. And we're going to say, yes, we allow the following rights, okay? Submit consent, redirect, and here we are, 127.0.0.80.82. We're calling the gateway here, not the backend resource server. But we're able to make the request. It's sending the request automatically for us, right? Because it's acting as a token relay in the gateway. And that so when that request gets to the backend resource server, there's an authorization header for the bearer token, and then the Spring Security Resource Server filter takes that and says, oh, okay, that token belongs to this auth server. Let me talk to the auth server and ask who that is. It's a user called 1, and then when we inject that, when we get access to the current principal, the authenticated principal using the security context holder, it's stuffed with the information that it read from the auth server, all instantaneously, right? So now I've got security in all my different apps. And you can do this anywhere. There are strategies to secure messaging flows with OAuth. You can configure and secure web apps, right? I mean, I'm making a request directly here. This is a little silly, but imagine my gateway code proxied, a Vue.js JavaScript app, for example. In which case, as soon as you make a call to / the JavaScript app would then force you to get a token by going to the auth server, logging in. You would be redirected back to the JavaScript app, being proxied through the gateway. And then now there's a session in the gateway. Whenever your JavaScript code makes a call to / API / whatever, that gets proxied now to your resource server. It acts as a token relay. My friends, we've just looked very briefly at the Spring Authorization Server. There's a good deal more possible here, but I really wanted to, and I probably will do more videos on this because I love the Spring Authorization Server. But what should be clear here is that it's easy, it's trivial to stand up an authorization server. These all turn nicely into native images that start up in a fraction of a second and take next to no RAM at all. And the auth server is just Spring Boot autoconfig. So if you want to store things in a SQL database, for example, or something else, there's implementations and you can write your own easily just by providing beans of the right type. It is easy to add things. Thanks for watching as always, and we'll see you next time.